All right, everybody, welcome back. So in this section, we're going to move on to part B of chapter 8, which is still to solve equations, solving quadratic equations, only now these are going to be set up to factor. So as you can see on this page, starting with 21, these problems now have a B value. Earlier, we had B equal to 0, and that's why we're able to solve with square roots. Well, in this case now, we have A, B, and C, so we're going to have to solve with something else. In this case, I'm going to tell you, and I actually told you the other way, I want you to solve by factoring. Now, this is actually a pretty big hint, because what I'm telling you is that I want you to factor just this expression, which then means that we're going to do something that we did in chapter 7, which is simply to factor this. So what do we do to factor? Well, I'm going to draw my box. And in the upper left-hand corner, I'm going to put n squared, the a term. And in the lower right-hand corner, I'm going to put 21, which is the c term. Now, to get these two terms, I have to come back up. And here's where I do a times c. And AC is equal to 21 in this case, 1 times 21. So what I'm looking for is two numbers multiplied to 21. So two numbers that multiply to 21, but add up to 10. And when I do that, it turns out that the only two that will work are 3 and 7. 3 times 7 is 21, and 3 plus 7 is 10. So I found them, and it's 3n, 7n. And these are both plus signs. Okay. Now, if you recall, to actually factor this, we're going to find greatest common factors of each row and each column. So right here, the greatest common factor of 7 and 21 is positive 7. Right here, it is n. Right here, it is n. And here, it's positive 3. So that means factoring from chapter 7, the factors of this would have been n plus 3 and n plus 7. Now, don't forget now, we're not actually factoring. We need to remember that this really was equal to 0 up here. So this is actually equal to 0. And now we can set up and solve this equation. Once we get our factors, the equation actually comes quite easily, because what I'm allowed to do is take each expression or each factor and set it equal to 0. So this little mini equation, subtract 3 from both sides. So n is equal to negative 3. And this mini equation, subtract 7 from both sides. N equals negative 7. And there's our solutions. So you can see that our factors are directly related to our solutions. It's just we have to factor first. This does not change. So again, we're really doing the same thing each time. It's just a matter of kind of repeating ourselves and getting used to it. Okay. As we move on.
Can you hold the office for just a minute, please? Wilfrida, Joanna, and Lisa. Thank you.
I apologize for that. Anyway, moving on, and we get to 25 again. We're going to get rid of the 0 and just simply factor this expression. So n squared goes here, 56 goes here. Now my a times c is 1 times 56, and that is 56. So I'm looking for factors of 56 that will add up to negative 15. Well, it turns out, as I start dividing 56, that I get 7 and 8, and as long as they're both negative, they will add up to negative 15. They will still multiply to positive 56. And there's my numbers. Okay, again, GCFs, -8, n, n, and -7. So my factors of this would be n minus 7 and n minus 8. Again, I'm remembering that this is an equation now, so I have to set it equal to 0. Now, both little equations so n is 7 and n is 8. So the factoring, again, is not going to change. We just have to factor and then solve. What I've noticed early on, though, is when we get into this last section of problems that we do have some difficulties. So the difficulty is that not so much really anything, it's that the algebra gets a little rougher. So on 44, the first term goes here, the last term goes here, and now I'm looking for factors of AC that add up to B. Here's what changes. A times C is now 15. So now I need something 15, factors of 15 that add up to 16. Well, it turns out it's 1 and 15. There we go. So 1x and 15x. Now when I do my GCFs, this is going to be a +3. Here it's only an x I can get rid of. Here, a 5x. And here, +1. So there's my factors. Well, now I need to set both of these equal to 0. In this one, the equation's a little easier. It's just 3. But in this one, the equation's going to take a little longer because I need to subtract 1 from both sides. And then I'm going to have to write this over here. When I solve that for 5 or divide by 5, I get a fraction as my other answer. So the factoring can be a bit of a challenge here. The solving's still no different. But again, we've done 3 examples now where they all relatively are the same. Okay, as I move on, I don't see anything that's looking too out of the ordinary. It is a matter of really looking at the work and figuring it out. So, oh, excuse us.
Vilma, Joanna, and Joy. Again, Vilma, Joanna, and Joy. Thank you.
Sorry about that again. Okay, so in 56, I'm going to have first term here, last term here. Now my factors of AC, this will get a little challenging. A times C is -70. So I have to somehow get to 9 from 70. This will be a little rougher. So what I'm going to do, if you can hear it, I'm simply dividing 70 divided by 2. Well, that's 2 and 35. That's not going to add up to 9. 70 divided by 3, that doesn't come out. 70 and 4, that doesn't divide. Oh, there we go. 5 and 14, I can get to 9. I can get to 9 if I do -14 plus 5. So even though this is a little more challenging, I'm going to have that. Now, GCFs. GCF. This way, it's going to be just a B. And this way, a negative 7. Again, it's negative because this number closest to it is negative. Okay. So there's my factors. Subtract 5 from both sides. Divide by 2. And there's my first solution. My second one, add 7 to both sides, and it's just going to become plus 7. Okay, so as you can see in this chapter, our job is to solve for x, or solve for the variable. It doesn't always have to be x. We have two ways to do it. We're going to do it by factoring or by taking square roots, both of which have the same set pattern. It's more just a matter of repeating yourself and getting these right. So go ahead and finish this packet, and when you're ready here in a little bit, we'll take a quiz on it. Good luck.